saying, okay, this connects to that block, this connects, sort of like a schematic diagram of how the different parts would connect together. And I'll just focus on some part of it to try to describe what it's, what it does to the program, because each of these does a different thing. Problem, this is kind of abstract and probably doesn't make sense to you, but another thing I'm going to do is, they have projectors over at the library. I'm going to bring one over, and I'm going to try projecting the program on that screen there, on that blackboard, or maybe on that wall or someplace. And they've done a job on this one. I can't do it here. So basically, I want to project an image of what the program looks like or what it's doing while I'm talking about the specific part of it. That way you'll have the whole program in front of you, and you'll be able to see all the connections. And then I'll just take one part of it and I'll start working on why I did this and the way it was done. And I think that might, I hope that might improve things. The way we're doing it now is I'm writing on the board, and if I miss anything, you can't just take the program and write it because it won't work. And that's just too likely with the board writing. So here's what I want to do. Today, for today's show, I want to cover some things about rotation. Some things that we haven't covered so far. I haven't talked about very much. We did do rotation in one of our programs. We actually rotated in the last program you wrote. You had something rotating, so you know how to use that WebKit rotation. But there's more to it than that. That rotation is just a part of how it really works. And what I want to show you today is how the rotation scheme really works, what it really does. So to do that, when you go online, you're going to see a program called Mirror. Mirror, it's called. And Mirror has a bunch of things in it that I want that are new, that I want to describe today. Actually, I don't think it's Mirror. I think it's called something different. Hang on. Yeah, Mirror is probably what it's called. Yeah, Mirror. And some other ones too. Let me just see that. I'm going to start with one that makes some sense to us. Rotation thing. Let's start off with the simple rotation. This program is called Mirror Webcam, and all it does is it allows you to see the image of the webcam backwards. Now that seems silly, but when you think about it, when you look at the image on the screen of the webcam, when you lift your hand this way, that hand on the screen goes like that because it's just shooting at you. It's taking a picture of you, so it sees you from the other position. But what if you wanted it to be a mirror? So when you move this hand, the image would move this hand also. In other words, you want to change it so that it's reversed what it normally is. It's possible to do that. And the way you do it is, it's kind of strange, is here's the image of the video that you're watching. What you do is, you rotate it over the y-axis, and you're looking at it from the other side. So in other words, the possibilities of rotation are actually much more extensive than we talked about. We have a picture, and we've had it rotate like this. Or back like that. We've had it rotate in those two directions. That's rotating something over the z-axis. See, the z-axis goes into the screen, so this is rotating over the z-axis. That's what all of the things we've been doing have been doing. And they have it designed so that if you just say rotate, it assumes the z-axis. That's what it assumes you're rotating over, okay? But there are two other axes. In the world, there's the x-axis and the y-axis, and the z-axis goes into it. So this is the x-axis, this is the y-axis here. So you can take this thing, and you can also rotate it over the x-axis this way. That's another thing you can do. Or you can rotate it over the y-axis, which is this way, which is how I did it to make the image backwards. I rotated over that axis, okay? So what I'd like to show you is the instruction set that allows you to do that, how it is actually done, okay? Now there are two things involved in it. One thing is, when you first set up the picture, you have to tell the image what position to be in. Do you want the x-axis to be rotated, or the y, or the z, or none? You can do that. You can say, I want them to be rotated or not. So when you put the picture down, If you don't say anything about the WebKit, that rotation, it won't do anything. But if you add the rotation into the thing, if you add the rotation commands, then you have to tell it where you want it to be rotated. If you want it to be rotated no place, but you want the command to be there, in other words, you want to say WebKit rotate this thing, but you want it to go no place, then you just put 0 degrees. You have it rotate no degrees, okay? And if you want it to rotate 90 degrees, you'd say 90 degrees. In other words, what you do is, when you first start off in your HTML, you have a style sheet which contains the WebKit and the WebKit rotation. And the WebKit rotation tells it where to initialize. Where is it going to start off? And then, in your program, if you're going to change this rotation or move it around in any way, then you have to have another WebKit instruction up here that says rotate the thing in different directions. Well, you know, this one and this one aren't written quite the same way. They're supposed to be equivalent, but they don't actually look the same, okay? And the reason why is because there are certain rules for HTML, the way you write things in HTML in a style sheet, and there's different rules for JavaScript. They tell you how to write things differently. So basically, you've got these two different ways of writing it, and that's one of the things I want to point out today is when you're writing an HTML command in a style sheet, you write it one way. When you're writing it up here in a program, you write it a different way. You say the same words, but you say them slightly differently. And that's what I want to get a little bit clear today, okay? So let me start off writing a simple program. And what it does is it rotates the video image 180 degrees over the y-axis, which is this way. So in other words, it goes like that. And we see the same image, but we see it backwards, which is like a mirror to us now, instead of being like a camera looking at us, okay? So let me just write that code. New color today. This was somebody in the math department suggested we try purple, see if it works better for us. This is the stuff that I'm going to stop doing in the next time we bring in a camera, a projector to see how this works. The source of this is so that's the, by the way, I've noticed also, if you leave this thing out right here, the new browsers are smart enough to know that you're doing it in JavaScript. They see the JS over there, apparently they figure it out. These are things that I always write formally because I'm always afraid that one of the browsers, if something doesn't catch it. So I write formally, but this thing right here is not necessary, apparently, in Chrome, because I've left it out and it worked perfectly well. So that's all there is in this program. There's nothing going on out there except for the fact that I have to include the mini webcam because we're using a webcam. It's going to be running the camera. This is the one right here. This is the big one, video. The video tag tells you you're going to have a video, but that thing up there tells you that the thing's going to be a webcam. There's nothing in here that tells you that. The webcam thing is all up in that mini webcam up there. That's the thing that turns on your webcam. Okay. You got to have this. Always put position absolute in if you're using a left or a top or a width or a z-index, or I believe it's also required with this WebKit transform. So always put this in, because what it means is basically you want the thing to be controlled by whatever instructions you put here. You want it to do what it's told to do, okay, where it's going to be and what it's going to do. Even if it doesn't say what the instructions are, if there are any, it wants to know what they are. So I'm going to put it left 400. Basically means I'm going to put the image 400 from the left side over there. Semicolon, top 200. Width 800. Okay, at this point right here, everybody in the room has seen these all. You know what all those things do, right? There's no problem with the width and all that stuff. You can put height if you want to, okay? The video won't like it if you do. It's not going to like that. But you can tell the video to have a width and a height. I don't believe it distorts. I think it just overrules you and says, forget it, I don't like you. It does what it wants. If you do it with a picture or anything else, it will do it for you. If you say, I want this to be 50 this way and 100 this way, by saying width 50, height 100, it will do it for you. It'll stretch pictures in any old way you want. Video, I think, acts a little bit differently. I think it's got its own mind. So don't attempt it with video. Video's got a proportion it likes, and it's hard to get out of that proportion. You can change it, but I'll show you. That's what we're doing now. We're actually, in a sense, we're changing proportions. This right here just continues. It's right here. There's a minus sign here, believe it or not. That's an actual minus sign, which is kind of peculiar, but they have a minus sign there. And another minus sign here, transform, all lowercase. And colon, the transformation is going to be a rotate. And it's over Y. The capital Y right there, that's a capital Y. That's, everything else is lowercase, that's a capital Y. 180 degrees, all lowercase. Good. I can't tell you how many times in writing programs that when I write this, I forgot that last thing, or I forgot that last thing right there. They've got to be there. It's one of those things, it's like, you have to close it. That's what HTML5 requires. Then I say slash body, slash HTML. Now this is the first program on the website for today. And what it does is, it does something slightly different than we've seen before. It does a WebKit transform rotate, which we did do before. We have done that before. But we never had capital letter Y in there before. That was not there. That's very unique, yeah.
Does the R on rotate need to be capitalized as well?
No.
Okay.
No. Sorry, everything here should be, yeah, it looks a little bigger, doesn't it? Just the Y. All lowercase except for that Y.
Rotate.
Very good, and it might be forgiving. It might allow you to put a small Y in there. I'm not sure, but a capital Y is what they say to put in, so I'm putting it in. Uppercase. That uppercase, lowercase thing, that may change as time goes by. So there it is. That's the what that thing will do when you run this thing. All it simply does is says, "Oh yeah, I have a video," and that starts running the video from the webcam, and then it says, when you show the video, rotate Y 180 degrees. Well, 180 degrees is like from here all the way to here. And here's something interesting. If you only rotated it 90 degrees, it would rotate to here, it would be out of sight. You wouldn't even see it anymore. So if you use 90 degrees, it would be that. This would rotate it all the way to the 180, okay? So 90 degrees is like puts it vertical to you. So you have to be careful with these things, of what number you put in here, and think of what it actually does. There is a program in the list of programs for today. I think it's one of the last ones. And what it does is it allows you to rotate the thing this way and over the x-axis, over the y and over the x-axis. And you have this little key. You just drag it around. You can watch the picture flipping every which way. So you get an idea of what the possibilities are. It actually, believe it or not, when you do it, you will see immediately that there's some potential for three-dimensional activity here. It looks almost 3D because you can see the thing float, going this way and that way, going, floating, twisting around. And so the two-dimensional screen had that potential for three-dimensional, to be done three-dimensionally. And ultimately, they made a thing which we're going to use at the last few weeks of the class for doing three-dimensional graphics, because they can actually make the screen look like it's three-dimensional. It's possible to do that, even though it's only 2D. Question?
So is this another webcam program that we have to test in Firefox because it won't work in Google Chrome?
Okay, here's what happens. If you run it if you run it on the black screen, you got it in front of you? You got a thing called launch.
Yours works, but I'm wondering, like,
Mine
if we
works, okay.
were to
Yes.
test this, we
Yes,
have to test it in Firefox.
this is the problem. The problem, first of all, it will run in your own computer. If the program and everything's in your own computer, you can run it in your own computer. This thing will run in your own computer if you have that in your computer also. Download it from my site. So if you have this whole thing in your own computer, it will run fine. If you put it up on Alta Vista, it won't run unless you put a secure socket layer, and you can't do that. There's no way to do that. So that's why I have these programs in this little black stuff. I put it aside because they're not like normal programs. You can't just run them like normal programs. You either have to have them set up the way I have them set up on my site, or the Dart site there, and that way, I think they charge you. I contacted Alta Vista, and they wrote me back and said, this is a mechanical something or other. We can't accept questions like this, so I got to go find some other way to talk to them. They always make them, they're bothered so much in these companies that you have to go through penetrate these layers to get to them. But I'll get to them, and I'll find out if there's any way for you to get SSL free. I get it because I don't have SSL. I didn't buy it. I didn't purchase it. But they had, on the site that I work on, they had some experimental things that you could do. So these are set up on this experimental site that just, they pretend to be SSL. They are really, but they're not the official ones. They're just, practice ones. They may have something like that at Alta Vista, I'm not sure. If they do, then all it simply means is, here's how you do. Instead of saying the name of your program the way you normally do, you put some more numbers and things around it, and that routes it through a different place, and it secures it. So it is possible that Alta Vista will let you do it, but I have to find out. I'm not sure yet. You could actually ask them yourself, by the way. It's pretty, if you can find a way to get a hold of them, just say a secure socket layer, can I use it? And they'll ask them what you need to do to use it. What you need to do besides give them $100. that's a different key. Okay, so there it is. This is the basic program, and it does what you want to do. And what I'm going to do now is I'm going to talk about some program instructions that work with WebKit instructions. I'm not going to write programs. I'm just going to write the instructions about what they do. And I'm going to write some instructions. I'm going to write instructions about how to deal with strings. There's a bunch of stuff that we have to actually do. And so what I'm going to do is I'm going to talk about these instructions on their own, what these instructions do. They are on the website. They're in the programs that are demonstrated programs, but I'm going to deal with them here just to say, here's the instruction, here's what it does. And then when you look at the programs, you'll kind of see how they're incorporated. Because there's no real way for me to write the programs. They're real long. And when you start writing programs, in the beginning, you're just writing a couple of things, but after a while, it gets so extensive that there's no way to do it. I don't have any way to. I couldn't do it on a blackboard or a whiteboard. I couldn't do it. Be sure I got everything I want here before I go any further. Okay, watcher. Mirror. Here. Shade. Okay, this is the one here. Okay, let me begin with the WebKit, because that's the thing that we're talking about here. So I might as well just go right into that and get that out of the way. I want to show you how all the WebKits, how that stuff works for rotation. Now, as is true with everything we do, there's lots of ways of doing stuff, and I'm going to avoid the ways that I think are not useful to us. I'm going to just use the ones that we can use. So there's two things. First of all, if you put into your HTML, if you put a WebKit instruction, and you want the thing to talk about how much is this thing rotated over the y-axis, how much is it rotated over the x-axis, and how much is it rotated over the z-axis, if you want to tell it immediately to have it rotate a different amount over each one of these axes, it's possible to do that. In other words, you can tell it immediately to be rotated over those three axes a different amount, different numbers of degrees, and here's how you do it. Now this is in the, I don't know if I should write the whole instruction. I think I probably should, that would be good, yeah. Okay, so let me do it. This is what's in the HTML video. By the way, that also works for pictures. It works for images also, but I'm doing it for video because that's what this program does. Okay, and I gave it a name, ID equals my video. And that right there, this has nothing to do with the transform. This just simply gives a name to it. This is all I'm doing. I'm saying I have a video and this is the name I gave to it. That's its ID. This is when you get into the stuff as a style. That's where everything starts to happen. Again, you want to be sure to say position absolute. Absolute. That. Left 400. And notice, by the way, I say top. Well, it doesn't make a difference. To say something that wasn't even true. 200. Width. 400. And there we go. That's that. Now, I would keep writing, but I'm going to write it down here. Now I'm going to put in the WebKit stuff. And here's what I'm going to do. I'm going to say I want the X to be rotated 0 degrees. I want the Y to be rotated 0 degrees, and the Z to be rotated 0 degrees. In other words, I'm initializing this thing in a normal position. The movie just looks like it normally looks. Nothing's been done to it. Okay? I can change those zeros if I put different things in. I could change them so they would start off in a different position. But I'm just going to start them off as 0 in this program. Okay, so here's what I say. I say minus. This is just continued like from over there. It's minus WebKit. Minus transform. Rotate. Like so. X. Capital X. X. Then I say 0 degrees. That's a 0 degrees. Then you make a space and you say rotate Y, capital Y, 0 degrees. Then you say rotate, give a space, rotate a Z 0 degrees, and then I think that wipes it out, and then that guy, and then that guy. Okay, so at this point, when your program starts, your video comes on the screen, whichever video you've got. You know, if you have a real name, you need source, and you say source, flying banana MP4 or whatever. But if you don't have a source, you're assuming you're using your webcam, so you have that webcam instruction up there saying turn on my webcam. So in other words, either you tell it, the video, what your source is down here, which is what we did in the early parts when we were doing just regular videos, or you have the webcam thing going on there, which you don't need a source then because that takes over and it says your source is your webcam. Okay, so that's the first thing. But nonetheless, whatever your video is, that means what it is. It's going to, all the picture's going to be shown on the screen right like that. That's what you're going to see. No degrees turned in any direction. Now the question is, supposing in a program like the one, for example, I have where you're pulling the ring around to flip the thing this way and that way, supposing you want to flip it dynamically. As you move this thing, you want the thing to flip, the video to flip on you, okay? So here's what you need. You need an instruction that allows you to change this 0 or this 0 or this 0 to something else. You need to change them to some other angle, Okay, so I'm going to work on the X and Y. I'm going to allow you to rotate over the X-axis or over the Y-axis. No, that's all we're going to do. We're not going to worry about the Z-axis right now. So let's just look at how you could possibly rotate over the X and Y-axis. What you do is your instruction looks like this. This is called My Video. So it would be My Video. This is up in JavaScript. And this is going to write the same thing as these controls down here, only it's going to be in JavaScript. This is a JavaScript version of the thing. Style. Because you've got My Video, and then you've got a style sheet, and then within the style sheet, you have the WebKit, and this is what this looks like. WebKit, and a capital T, transform. Notice the difference. Down here what it does, it says WebKit -transform -rotate. But up here, what you do is say WebKit and you use capital transform. It's the same thing, except this is the JavaScript version of that HTML down there, okay? Equals. This is where it gets kind of weird. I'm going to write this down, and then we'll describe it. Let me write it first, because if I keep talking while I'm writing it, I'm not going to do it right. Plus, I'll just put a value in here. What value is actually the number of degrees you want it to rotate. This is the number that you say, I'm going to rotate as many degrees. Plus, let me keep going here. Degrees. Then it closes. Then there's a space, and then it says rotate. Then it goes like this, closes, yep, and then it says plus. Degrees, I'll say degrees, which is a different number than that one, because you want to rotate over one axis different than the other. Make sure I got my stuff here now. Take the X now, I didn't. I missed it. This is capitalized here. And this right here is capitalized right there. Degrees plus quote. Degrees. That's it. This looks awful, but it's how you do it. There's nothing else you can do about it. Okay. This actually, it's actually very, very hard to deal with this thing, but here's the idea. This thing over here says you rotate X over 0 degrees, okay? So what happens is, in JavaScript, what happens is you're going to send this stuff off to these functions that are going to do this job for you. The problem is that these part right here is the beginning of a function. That's the beginning of a function here. And this right here is the name of the function. It's rotate X is the name of the function. So what you do is you send, quote, the name of the function X, and then open up that parentheses and say, quote, again. So in other words, that gets sent. It's just like sending this stuff right here. Just all these things from here to JavaScript. It sends those. And then the real number is the one that you're going to change. So that's a real number. So you say plus that number, whatever it is. You put that in. Plus. And then you go back to this thing over here. You want to catch, you have to say the word degrees, which again, this right here, all the way up to here, is just a string. No, this is just a string right here. It's just these exact words. That's a real number. And then these exact words. And then that's a real number, which is right here. And then, because you said everything from here to here is just a string. And then you send this number right here. And then you send this string over here. So in other words, here's what it looks like. You got this string goes from here to here. You got this value right here. and then you send another string, blah, 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 and then you get this value right here in between. It looks very awkward, I understand. It's very strange. So what's happening is, though, we're sending this thing, we're sending that number, and we're sending that word, and then we're sending these words here, and then we're sending that number again. So in other words, the only variable in this whole thing is the two variables you use to say how much in the x direction and how much in the y direction do you want to rotate this thing. See, those come in from up here someplace. You've calculated what value is and what degrees are. You calculate those two things, and then you say rotate in the x direction that number, whatever it is, and you rotate in the y direction that number, whatever it is. That would be the same thing as having put whatever the value of this right in here, and whatever the value of that is right in the y right here. But we aren't putting anything to z. I didn't put anything to z. It doesn't change. So z stays at 0. It doesn't do anything. So in other words, here's what happens. When you're writing your program, when you're writing HTML, you write it like this, with no parentheses or anything around all this stuff. You just write the real numbers that you really intend. But when you start using variables, and this is a variable right here, and this is a variable right here, you have to surround it with all of the other stuff that goes with this instruction by putting in quotes. That's the idea. So this whole thing right here is all just one great big piece of, you put that in, then you put in the number, then you put this great big piece right here in, then you put in the number, then you put this last piece right here in, and the numbers are the only things that actually are not data literals, they're just numbers, values from a variable someplace. Does that kind of make sense? It's kind of strange though, it's a strange way to do it. But what they require is, because of the relationship between HTML and JavaScript, it was a very weird relationship. These guys here can directly address this is the function and there's the thing they're sending to the function. We can't do that, there's no way to do that. So they say, well, we'll do this part, and then we'll send them these data literals, number, data literal, number, data literal. And they'll get everything they want. We just have to set it up differently than HTML sets it up. We have to actually explicitly say, these are the words, this is the number. And that's how it works. So what happens is, if you wanted to, when you look at the last program in that black screen, the launch screen I gave you, you'll see that it has this thing right here, this instruction. And what that instruction does is, you get your mouse out there and you're moving it around. Whatever you decide to do in the x direction, actually in the y direction, whatever I do in the y direction, I put in this value. And whatever I do in the x direction, I put into that value. By the way, there's a reason why I do that. Think about this. This is rotating over the x-axis, like so. It rotates this way over the x-axis. So the logical thing for you to do is to move the mouse up and down to rotate it, right? So obviously, the mouse Y location is telling you how to rotate over the x-axis. So in other words, this thing right here, where the x-axis, this would be Y, this would be a difference in Y. What is the Y mouse doing, which controls the x position? And then this one over here is the x mouse. Because when you move x this way and this way, you want your thing to rotate over the y-axis, depending on where the x mouse is. So it's just for your own, you could do it the other way. You could make the y-axis turn to y, but it looks kind of crazy. If you move it this way, it looks perfectly logical. Do you get what I'm saying? So weirdly, you have to use the other direction, because your mouse is in this position right here. It's changing x and y. You grab that from the mouse, because we have a mouse command that says, here's where x and here's where y is, and you say, this is what you want to do. So in other words, the function's easy to do. It's just take the x and the y and put them in there. So there it is. There you have it. That's how you deal with these transformations. If you had a z, instead of just an x and a y, and you had a z, you'd have to do the same thing. You'd have to take this part right here, only would say z right there, and then you have to have a new number, and then put that on the end. So you'd have, instead of just two of these, this and this, like that, you'd have to have this and this again, and then finally that on the end. So basically you have to do it for x and y and z. So you'd have a rotate x, a rotate y, and you'd have a rotate z. All cap, this is cap, this is cap, this is cap, and all the rest is lowercase. Okay? And that's how it works. And by the way, you don't have to turn x and y, you could just change z. For example, you could call this rotate z, put the number for z in here, and then just put this on the end, and you wouldn't have to do the x and y. Whatever one you want to change, you can change. as long as you know what you're trying to do. So you could just turn it this way if you wanted to. That's it. That's it for that. And I hope that between the programs, looking at the programs and how they work, and this right here, it'll make sense to you. All right? Because you have a choice. You can either use these things or not. If you don't want to rotate over the third dimension, you don't have to. It's up to you. As I say, we'll be doing 3D graphics at the end of the course anyway, which is totally different than this, but you'll have that capacity after a while anyway, using a different way. Let me see what else we have here. For this program, not much. This is the last program. It's called Shade. Let me see what else we got here. Yeah, okay. Next thing I want to do is I want to talk about the if statement. The if statement we did a little while ago allowed us to say if A is equal to B, do something. If A is equal to C, do something. And I never went beyond the simple comparisons to see if they're equal or bigger than or smaller than. That's all we did. And we haven't actually used them for very much, but now I want to show you one more variation in them that helps. I like physical comparisons of things. Okay, so for example, if I had a barn, and the barn had two doors in it, this door and this door right here. There's two doors, okay. Now in the real world, we solve problems like this without even thinking. We don't have to even think about them. We know exactly what to do. If you have to go to the barn, and sometimes one of the doors is locked, you're going to try that door. If it doesn't work, you're going to go to the other door. In other words, you're going to if either one of those doors is unlocked, you're going to the barn. You want to go to the barn, okay? So you know immediately, you say, okay, one of these doors has to be unlocked or I won't get in. And so the way you say that in English would be, if either A or B is open, if either one of those is open, I can get into this barn, okay? There's an if statement that's equivalent to that. Let's say O is open. I can say if A is open, or if B is open. In other words, what I'm saying in this if statement is not just if A is equal to something. I'm saying if it's got a certain characteristic, being open or being 3 or being 5 or being 7 or whatever it is, or this equals 7 or 9 or 16 or whatever it is, if either one of these is true, then do this. Whatever's here, do it. In other words, this is an if statement that says or. It's an or statement. That's an or right there. And it's two pipes. They're on the right-hand side of your keyboard. They're called pipes. And it's right where, it's right below the backspace key on this one, the del. But it's, I don't know where it is on your keyboard, but basically it's in the upper right. And sometimes it looks like this, and sometimes it looks like that. They draw two different ways. It's called a pipe, okay? This thing with two lines like that is not really two lines. It comes out as one line on your screen, so you don't see two lines. So that's it. That's the or statement, okay? Now, there's another if statement which is kind of interesting, and it's also involved like this. Supposing, for example, you have to go into the barn, and the barn's arranged like this. Now you can see the problem is both A and B have to be open if you want to get into the barn. They both have to be open. That means if A is open and B is open. And here's how you write that. You say, well, if A is open, and these ampersands, there's two of them. The ampersand on your keyboard, there's two of them, just like there's two of these, there's two ampersands, and B is open. Then do this over here. So that's the question. The question says that if this or this is open, that was the original kind of barn, you can get into the barn. In this case, it has to be if this and this both have to be unlocked, that you can't get in. And that's the way the AND statement works. So there's two different kind of statements here, and they both do their jobs in logic, just like we have to do in everyday life, but we have to have a way of saying it. That's how we say it. And there's one of the programs we have actually asks this question. And we're not going to get to the program until next time, but I want you to anticipate how it's going to be used. Did you ever hear of a language called Pig Latin? My mother and father used to use Pig Latin, so I wouldn't understand what they were saying until I was like 18. Then I figured out how it worked. Then they started spelling. That went over your head. Anyway, so the way Pig Latin works is this. There's many versions of it. Suppose you have the word apple. It starts with a vowel. And if it starts with a vowel, you just simply add AY at the end of it. And you say it apple A. That's how you say it in Pig Latin. You just add AY to it. That's one, this is, as I say, there's many versions. This is one common version. Suppose you have banana. In that case, you look at it and you see this is a consonant right here. So what you say is you pull it off, you add it to here, you add AY to the end. In other words, you take that consonant, put it on the end, then add AY to it. So what happens is this turns into apple A, and this turns into ananabe. They turn into different things. People can actually speak like this rapidly and know exactly how to do it. You get really good at it after a while. Okay, so you can see the problem here is that if the thing is a vowel, you do a certain thing to it, and if it's a consonant, you do something else to it. Well, in the if statement, that when you see a word come into your program, and you have to figure out how to translate it into Pig Latin, the first thing you have to do is look at that first letter to say, is this first letter a consonant or a vowel? So you say, is it A, or is it E, or is it I, or is it O, or is it U? So you have a bunch of ors in there, right? It's almost like a Greek rowing boat or something. You get a bunch of ors in there. So you got all these ors in here, and what it says is if any of these are true, if it is A, or E, or I, or O, or U, any of those is true, do what you have to do. Assume it's a vowel, and then you treat it like this. Otherwise, you say have an else, and you simply treat it like that. Pull the first letter, put it in the back, and add AY to it. So in other words, when your program's translating into Pig Latin, all it has to do is determine whether that's a vowel or consonant. That's all it has to make a determination. And that if statement does that for you. Okay, now, the next question is, and it's a different question, is how do you pull that first letter off once you've decided that it's a consonant and you have to put it at the back end? How do you do that? Okay, so here's the question. I'm going to diagrammatically do this. In comes, somebody types in the word banana. And that's the word that comes in. We'll say it just comes in. That's the word right here, banana. So what we want to know is that a vowel or not? Well, we have a command that allows us to look at that, don't we? I can look at the first letter of any string. I can look at the first letter because I can pull it off. I can look at it. Agree? Everybody know you can do that, right? So what you can say is, well, you can call it position B or something like that. Position band. Remember this? Equals, and then you have the word banana, the word, whatever it is, dot index of, and you're looking for, wait a minute, I can't do this, sorry about that. You can't do it this way, sorry about that, sorry about that. What you have to do now is quite different. It's quite a different thing. You can't just do it that way. What you have to do is pull that letter out. This is after you've made the determination. In other words, it's not apple. It's not apple. So it contains A, E, I, O, U. So let's assume at this point, when you come to this thing here, you assume this word is now a consonant. You know it's a consonant. Okay, you want to get that consonant out of there. So what you do is you say this. This is the new part in which I should have talked about before. You say your consonant, I'm going to call it con, so say it's a variable. I pull off the consonant. What I do is I say, go to the word right here, and substring. Okay, let me describe this to you. Here's what this thing is right there. This is the new part right here. Okay. What this thing does is, I'm saying, in that word, this right here, that word, I want to take a piece out of it. I want to take a character out of it. I want to take the first character. Every character in the word has a location. The first character is 0, the second character is 1, third character is 2, and so forth. Each character has a number associated with it. What I'm saying here is I want to take a piece of that, starting at position 0, which is the very first character. I want to take one character. So what I'm saying is, in this expression right here, starting at the 0th character right here, I want to take one character. So it takes that character right there and puts it into here. That's the consonant. I now have the consonant. Okay? That makes sense? So what you can do with a substring is you can pull any characters you want, any number of characters you want. For example, supposing I'm leaving the program now, the translating program, but I'm going to other possibilities. Supposing I wanted the first 3 characters here. I would say consonant, or whatever it is, whatever variable I use, from word, take the substring, by the way, it's str, it ends with r, starting at 0, take 3 characters. And then those 3 characters will be transferred into there. It doesn't hurt the original. The original word stays the same. It doesn't do anything to it. It just copies those 3 characters out. Okay? So that right there is how you grab characters. You take them out of things. There's another instruction. I'm going to show you the other one. This is why I showed you this one first, because this is the one that works exactly how you think it would work. Start at the first character, pull 3 characters, and starts at this one, and next one, and pulls them out for you. Copies them for you. There's another one called substring. And it does something quite different. It starts at the original character, we'll call it the first character, whatever character you pick down here, like character 5, for example, and it goes to the character, whatever character you want. In this case, we're going to character 9. 9 right there. So what this one does is, it starts at the 5th character, 1, 2, 3, 4, 5, and then it goes to the 9th character, 6, 7, 8, 9, like that. That's what it's supposed to do. But unfortunately, they didn't write it correctly. This is a very peculiar instruction, and that's why it's not very useful for a lot of people. But here's what happens. It will go to the 5th character, and it will start counting up to 9. The trouble is that it won't get the 9th character. To get the 9th character, you have to put a 10 here. So it goes up to, but not including the last character. And that's the big problem with it. So let me write suppose I said, this is a phrase right here. Phrase. Like so. Supposing I said, start at the substring. Yeah, so I want to get the is a. I want to get these 2 things out. So I would get 1, 2, 3, 4. I want to get these 4 things out right here. So I say, okay, starting at 0, 1, 2, 3, 4, 5. Starting at 5. And I want to go to 5, 6, 7, 8. I want to go to 8. If I put an 8 right here, which you would think I would have to do, I will only get is blank. I won't get the character I want. So what I have to do is I have to write a 9 here. In order to get the 8 over here, I have to write a 9. 5. Did I count these right? 5, 6, 7, 8, 9. I'll get a blank too. Sorry about that. Not very good arithmetic here. But the idea is that when you use the substring, it will pull it out and put it wherever you want, but it will pull the wrong things out if you don't do it just right. So basically what I did was I wrote this little program. It's on the website. And you got both of them right there. You can actually write your own phrase and type numbers in and see what it does, see what it gets for you. It's a simulation of how things work. and you'll get used to which is which. Because after we get through this program next time, which is just not a big program, from then on, we may have to use this instruction for many things. And in fact, I used it in one of the programs today, and I'll show you why and what happened. I wrote this program called Watcher, which is where, theoretically, when you run the program, there's this funny looking guy there, and he's got two eyes, and when you go like this, the eyes follow you. When you go like that, the eyes follow you. So no matter where you go back and forth, the eyes follow you, okay? And all this is cartoon characters, all cartoon. And the question is, it's really easy to do that in 3D graphics. It's quite an easy thing to do, and with a webcam and everything. But it's not easy to do in 2D graph. In fact, I've never seen it before. But I had to do some really crazy stuff to do it. And I'd like to do is spend a few minutes telling you what the problems are when you try to do something new, what the obstacles are, what comes up. Okay. So here's how it began. I thought to myself, well, I'd like to write a program where the eyes follow you, where you go this way and you go that way, the eyes follow you. But I have to write a really complex routine to make that happen. But I already had this program we used last time where the character, you put a mustache on him, when he goes this way, the mustache stays with him, goes back and forth, okay? Well, the way they did that was, they had the video, and they did some work in the video, and then they simply put the picture, the mustache picture, right on top of it where they wanted to. In other words, they decided where its left and where its top was, and then they printed it right in front of them. So in other words, what they did is, they watched the video to see where the character was, because they had this thing like a photography thing. And so they said, okay, now he's at left, 100 and top 30. So they put the mustache at 130. They printed it, they put the image there. That's all I did, move the image to that position. So then I realized, they said, okay, so what they're doing is, I put this picture in, and they're moving that picture to a different position, so that every time they move that thing to a different position, I now know what the left and top of that mustache is. I know where it is. And because when I go back and forth, the left and top are going to move back and forth. So in my JavaScript, I can look at that and say, where did they put the mustache this time? Okay? So what I did was I said, okay, now I sort of got an idea here. I said, if you started off there, and you have this thing with the mustache already, here's the character with the mustache, and you know that wherever he moves his head back and forth, this mustache moves back and forth with him. Now what you know is, the distance between here and here, you can find out what that is, because you can simply look to see what the current left side of that mustache is. Where's the left side now? Where's the left side now? And by doing that, I know where they're putting this mustache, painting it on top of the video. So I did. I wrote a little routine up in JavaScript. I said, where's the mustache? And so then what I realized was, this was not going to work easily, because if I simply covered this up and put a mustache in front of it or something, or eyes in front of it, what would happen is, as I moved this way, it would move that way. And if I moved this way, it would move that way. So in other words, the eyes wouldn't follow me, they'd be doing the opposite, because of the way the thing is not mirroring me, it's just doing what it does. So I tried to turn on the mirror. I turned on the mirror thing and tried to do it, but their routine didn't like that, so it wouldn't allow me to use the mirror thing, so I was stuck. I only had the numbers they gave me, which were reversed. So I simply made them negative. I said, if I move 3 to the left, move 3 to the right. In other words, I took their numbers, I read the numbers they had, which way they moved the mustache, and I said, okay, move the eyes that I want in the other direction. So I set these two eyes in front of the thing. They're in front of this now, in front of it. And when they moved left 20, I moved my eyes right that same amount, the exact same amount as they moved them. So then what happened was, when their things moved left and right, mine would move the opposite, move right and left. Then I made them very big, then I put a face in front of it, and I blocked this out with a white panel. I could have done it by simply making it, obfuscating it to 0, but what I did was I left it there and I put a white panel in front of it, put this guy in front of it with the eyes, and then put the face on top of that. Then the eyes moved back and forth through the holes in the eyes, and that's all it did. So basically, it was a big rigmarole. It was a big bunch of stuff. But in order to do that, what happened was, this is the part that I wanted to get to before we go any further, is that when I asked them, where is this thing now, it didn't just give me a number, it gave me the number PX, which was really weird, freaked me out a little bit. I wanted to know what's my left side, and instead of getting just a number, I would get like a 500 PX. Try to do arithmetic on 500 PX, and it's not going to work because PX is in there and it gets in the way of arithmetic. So you can't say reverse this, make it negative. You can't make it because it won't work. So what I had to do was, I had to use one of these guys right here to pull my number out. So what I did is, I started at 0 and pulled 3 and grabbed the 3, because everything's in the hundreds. It was always in the hundreds. So I grabbed these 3 things here and I put it into a number. I made a number out of it by putting capital NU, blah, blah, blah. And so I took the 500 away, turned it into a number, and then used that to move my character around. So in other words, these are the kind of things that you come up against. So I mean, if you're using someone else's software, you don't know, what exactly they're doing. But once you start printing out what you see, like all I did was I just printed out the numbers. I said, when they move it to the left, print out the left side of the mustache so I can see where it is. I printed out the number. It said, out 1 dot something. What is the location of the left side of the mustache? So it actually gave me the number. So basically what happens is when you're solving these problems, you have to always think about the idea of, if it doesn't do something you expect it to do, just do a little printout, make a little out area, and say, print out the number at this point so I can see what's happening when the thing's moving around, so you get an idea where it is. And these little holes that you have to get into the program, you have to figure out how things work. But in the end, what happened was this thing works. It's kind of chattery. It isn't very good, but neither were the original mustaches. So the eyes weren't really very good. But it did it. It did what I wanted it to do. And what it took was, it took not only having that whole bunch of things which were required to make the mustache there in the first place, but then it required me to read where the mustache was, convert it, do a little arithmetic on it, and then tell the eyes where to be. And that's how it worked. That's how the program worked. If you look at it, you can see the details of it pretty clearly there. There is a lot. It's not a giant program, but it's got one function here. It's got a lot of stuff in it. Another thing that happened was, and I'll just explain this quickly, you had the guy's face, like so, and his eyes, and in the eyes were these other eyes over here. So the question was, if you move too far to one side, what would happen is the eyes would pop out of his head and he'd be over here. So I had to stop that. So I built a couple of if statements that said, when you get to this thing over here, don't go any further. And when you get to this thing over here, don't go any further. So the if statements just simply kept it in the range. So it said, well, if it's less than 200, make it equal to 200. Don't go into 200. I just forced it to be the same number, so it would always stay within that range. And that's part of the deal. But all these logic problems you come up with when you're writing are immensely important, because no program, I mean, even the easiest things I've written have come with, there's always something. There's always something you have to work out the details of. In the programs we're writing, fortunately, my plan is for you to just use programs that I've written and sort of alter them a little bit. But even when you alter them, they can do something weird. So you have to think about, what would that alteration do? But I'll tell you one thing, from the emails I've gotten hundreds of them from students at this point. There are a lot of students in this class, as you know, aren't here. And what I've discovered is that I would say 99%, and I'm not kidding, it must be 99% of the problems are just typos. They know what they're doing, they just don't type the right stuff. And it's amazing. It's just, a program is like one great big password. And if you type one thing wrong, it's not going to work. And that's exactly what programs do to you. It's the same thing, they just don't work. And that's the problem. It's hard to get used to the idea of having to do something that's so precise. So you got to get punctilious, and it's something that's hard to do. You can't just teach that. No one can teach that. You just basically have to practice it, or Some people are very good. They're very precise. I've known people who are scientists. Their precision in science was perfect. I mean, math and science was perfect. But if you went into their offices, you might get hit by an avalanche of books or something, because their life is a mess other than that. But some people choose when to be perfect and when not to be. I think I've just about covered that. What I want to do now is I want to show you a couple of these programs. Remember, you can use these programs if you download them to your machine. They'll work in your machine. They will not work on your website, Alta Vista, unless you get SSL or whatever site you're on. You have to get that security clearance. And the reason why you can run mine is because these are run with a security frame. They're different than, oh, yeah.
So because we need SSL